Yeah, let me know whenever.
Okay, we starting. Facebook is like this time. Okay. To go page, share on a page. In a few more seconds.
Sure.
Okay, perfect. So we are live.
Great.
I don't know if you can see us, see me. Let me make sure I change the view to gallery for a second. Okay. All right, perfect. So hi, everyone. I'm Celeste from the New Haven Free Public Library. And we have Page today with another session on creating a digital instrument on our sessions of Learn to Code. So I'm here to help with anything with the chat, and I leave it to Page.
Cool. Yeah, thanks. So the past sessions that we did about a month ago, or that we finished about a month ago, we were using something called Pure Data, which is like a graphical programming environment and like software that lets you create musical tools and instruments and all kinds of different things. So we wrapped that up, but this time I wanted to demonstrate more like code for people that are interested in basically using like a conventional programming language to make audio or to make sounds. So the first part of this will kind of be talking about, you know, like how that's typically done or how that's like approached. And then the next part will kind of talk about how to do that in JavaScript, and which is the language we'll be using for this purpose today. And then the third part is going to be kind of a demonstration of like how to do that in JavaScript. So yeah, like I'll run through like a little demonstration of some code, and we can tweak it and modify it and make some different sounds. But yeah, before I do that, I just want to mention really quick, like I have office hours with the library, and I do those every Monday evening. But of course, you can email me if you want to schedule something outside of that, like if these times don't work for you. But you just go to Calendly, this URL here, /coder NHFPL, and then you click on one of these Mondays, and then it should give you the blocks of time that you can schedule. And then my email with the library is coder@nhfpl.org. So yeah, okay. So yeah, I'll go ahead and get started. So this website I'm at is like a publicly hosted GitHub repository at my GitHub address. So if you go to this is probably the easiest way. If you just go to github.com/Page Swanson, which is my name, you can click repositories, and then it should show you the most recent one. So this one's called Small Synth with JavaScript. So if you click that, and you just click intro, and that'll take you to the lesson if you want to follow along on your computer. Okay, so kind of getting started with this topic. Yeah, so audio and programming. Like I said, we had some previous sessions where we've worked with programming for audio. But this is a little bit different because we're going to be using like a more conventional programming language. We're going to use JavaScript to do that. So there's kind of a different way of thinking about it. So to start off with, like programming languages historically, things like you might be familiar with Python or C, C++, Java, things like this. They've always been like supplemented with libraries for computer audio. This is like just a thing that we wanted for a programming language for since nearly the beginning. There's this language called BASIC. If you're if you had a computer in the 80s or something like this, it would sound familiar, but there was this programming language called BASIC. Even it could generate audio. It had tools that you could use to create audio. So this is like a task that programmers and developers have been interested in for a long time. And basically the way this works is, or the way this is typically approached is, someone figures out, like you have the computer and the computer has speakers, and it has different ways of devices inside of the computer that hooked up to those speakers. And then obviously the computer is running software so that you can do different things. And someone at some point, a programmer or a developer, figured out some code or wrote some code that makes requests to the computer, the hardware, to produce audio on the speaker. And usually that's done with like something called like a stream or a buffer, but this would be in software. So in software, there's a stream or a buffer, and this inside of that is like the audio that you want to send to the speaker. This is all digital. So you're doing this using code or software. So that has to exist, right? You might call this like an audio interface or something like this, a software interface. There's tons of different ways of doing this. There are different operating systems like Windows or Mac or Linux and things like this. There's different ways that this has been done traditionally. But the point is that you can reference the audio output of your computer using this stream or this buffer, and there's going to be an audio like library in your chosen programming language that's going to let you do this. So C++ has one, they all have one. For the most part, it's like I said, it's a very common task. Most people want to be able to play audio. So secondarily, that's just to get some audio, right? But it's not going to help us figure out like how to make a certain type of sound, like a piano sound or something, or it's not going to necessarily help us make something sound like something in particular, or like to play a file, something like this. So that would be like what typically people would call like the audio engine, which is just another library. And when I say library, that's just like basically a collection of code that someone has written for a certain purpose that you can then use and reference with your code. So if I have a library, I write some code and I say, I want to do this specific thing. I need this library. I'm going to write some code that uses the library. So that's how we relate to different pieces of code, is through libraries. Yeah, so then if we want to do things like make sounds, so make sounds to play on the computer, then we use something like an audio engine or just another library for generating signals, digital signals. If you were part of like the pure data sessions that we did at the library, pure data is all of these things kind of in one. So it's very much like an audio engine. It lets you like make all of the sounds that you want and then send them to your computer. So the idea behind doing this is when someone makes a library for generating signals, like an audio engine, the point is like, I don't want to force a programmer in their programming language to have to painstakingly create like every little fraction of a sound, right? Like if I want to hear the sound of a bird, for example, if I don't have an audio engine, then what I'd have to do is I'd have to write some code that says like, okay, the sound a bird makes first starts with this little sound, and then I add this other little sound, and then this other little sound, and this other little sound, and then eventually I get the bird sound. That's not very productive. So people write these audio engines or these libraries, and then maybe they provide you with some code that just says, make bird sound. So then in your code, you just say make bird sound. And as long as you have that library, all of a sudden you can make a bird sound. This is what we want to do today, basically. This is our objective, is we want to use a library that will just readily provide us with things that make sounds and connect to our computer to do that. So like I said, you can call a function or something called like make bird sound or whatever with some parameters, meaning like, different options. So maybe you want the bird sound to be very loud or very quiet, or you want it to be at a certain pitch. And this is going to be a very convenient way to add to the stream, which we talked about up here. So the interface to like the computer speakers, so that it makes a sound. In this example, I'm talking about a beep. So yeah, like I said, this would typically be called like an audio engine. The reason it's called an engine is because it implements certain ways of doing things. Typically, I would say maybe like, usually when people are describing engines, they're talking about something that is handling systems in a way, in a very kind of like particular way, all like kind of uniformly. So like there's physics engines. So physics engines basically allow you to do things like, if I throw a ball, the physics engine, the code that someone wrote to handle physics, is going to do all of the physics stuff for me when the ball is thrown. So like when you play a video game and you throw a ball, there's a physics engine in that game that says, okay, they threw a ball. I need to dictate how long it's going to take for the ball to be thrown and then hit the ground, etc. Same thing with an audio engine. So an audio engine in like a video game, for example, would dictate like, if you punch someone, and a sound is made, how long does the sound happen for, and how do you hear it in your headphones, stuff like this. So these are typically referred to as engines because they're handling a lot of different processes as consistently as possible, kind of like the real world. So I provided some examples of stuff. I mean, I wouldn't expect anyone necessarily to like be able to dive in, especially if you're just being introduced to this stuff, but they are pretty interesting to just take a look at. This one is a C or C++ library, and it's an audio I/O library. So this is at this level, this bullet point that I talked about here. So someone figures out some code that makes requests for the computer to produce audio. So that's what this is. It's not going to help you like make certain sounds, though I believe they do have examples of making certain sounds. But this is what this is going to do, is basically help you talk to your computer. If you were writing like a brand new C program and you wanted to make some sound, you would need to get this set up, something like this set up first, so you could actually tell the computer to make sound with your program. So this is what we typically call a pretty low level library. There's this one, which is libsound.io. This is very similar. Like it also just basically helps you tell the computer to make some sound. They even include an example actually, which I like because I think it demonstrates like why this is not an audio engine, because this is what you have to do using this library to make a sine wave, like just this very simple wave. It's a lot of code to do that, and it's quite complicated because they're not using an audio engine to like make sounds to then play on the speakers. They're just using their library to play on the speakers right here. So sound.io is what they're using to play on the speaker. So eventually here you'll see they have a stream, sound.io, outstream, and write. So eventually they're going to make the audio that they want to play, and then they're going to send it to the computer. But they had to make all this audio, and it's a very painstaking process. Like this is what I was talking about with the engine part. So no one really wants to do this. You want something like this. You want something that someone has made for you that helps you produce audio. So, I mean, this is totally fine. There's nothing wrong with this, but it's just they're not using an engine here. So if you combined this with an audio engine, basically a way to make audio quickly, this would be very helpful. And a lot of things, all this stuff is rolled into one. So you don't have to do all this stuff separately if you don't want to. So enter things like Python. Python has very, what are typically considered trivial ways of producing audio. So I think Python typically does a very good job of helping you interface with audio. And you'll notice here, you can use like this library, for example, Pio, as an audio engine. So they reference different pieces of software that are using Pio as an audio engine. But it mentions here, Pio specifically is a module that helps digital signal processing script creation. So basically, like, it helps you make different audio scripts. Yeah, so again here, like, it's not going to basically tell your computer how to play a sound, because the Python programming language happens to have nice native stuff for being able to do that. But it does help you create audio signals that you would then want to play. So this is what's very helpful about this. So you could kind of think of like, if you had this in combination with something like one of these, then now you can make audio very quickly. But of course, these are different languages. So you wouldn't really do that, but hopefully you get what I'm saying. Here's another example of like an audio engine in a different language. I like the way that they put this. So it's, you know, nice and not stupid. But the point of this is, again, same thing. It lets you do stuff really easily with audio without having to think too hard about it. So this is pretty cool. Like, it lets you open sound files. So like an MP3 or a WAV file that you have saved on your computer, like, and because of this, you can start to think about all the different things that you might do with this. Like, I think this is very cool because it lets you open a file to get ready to play it as audio. You can then like trim the file down. You can make it louder. You can append to it, like have audio and then make the audio longer. You could loop it, like repeat it. So this is really cool to me because all of a sudden I start thinking about, like, you could make like your own version of iTunes or something, like, or you could, I don't know, make your own music player or things like that. So, I mean, this is why audio engines are very helpful, basically, because otherwise you'd have to do all of this stuff manually, like with your own code. So this is why people use audio engines. Yeah. So again, notice here, I'm pretty sure, I don't know if they'll actually, yeah, it might not show us here. I mean, if we were to look inside of like the implementation of this engine, we would probably see where it talks to the computer, because it would need to do that at some point. It might be sub-process. Yeah, it might be this player. Possibly. Oh, okay. They're using Pi audio. So for the Python programming language example, PyDub is like the audio engine, so we can make different pieces of audio to play. And then Pi audio, which they're importing, is how to talk to the computer. So that's how Python talks to the computer. So once you have both things together, now you can do a lot of stuff very easily. So anyway, that was a little bit of a deep dive, but we're not going to be using Python or C today because we're going to be using JavaScript. So JavaScript, which I've introduced before, but I'll mention again, is basically kind of the language of the web. It's the scripting language for web applications. So most websites that you visit and most of the web today is basically using JavaScript to do what it needs to do. It's very powerful and it's very easy to use. I think it can be hard to use as well. It can definitely be very complicated, but I think it's also quite nice to use. And it's very accessible. Basically, as long as you can go to a web browser, you can start programming in JavaScript. You don't even need to be connected to the internet. So it's very nice. As long as you have a web browser installed. So why are we using JavaScript? Well, JavaScript has this really, really nice API. An API is, what does that stand for again? I think it's like something programming interface. Not the American Petroleum Institute. There it is. Application programming interface is what that is. So what does that mean? I think honestly it's a pretty vague definition, and I've heard tons of people describe it in different ways, but basically I wouldn't worry too much about it. Basically it just means like someone created a library, and normally a library might not have a super like helpful way of accessing the code within it. And a library, by the way, you can think of actually as like a real library. So like when you think of a library, it has books like the New Haven Free Public Library does. And then you go and you access those books. It's just like a code library. So a code library is just a library of code. So you go in and you access the different pieces of code that you want. An API basically makes an interface for accessing all of that code, but it's a very strict interface. So it's kind of like saying, you know, you have this library, but I don't want you to do whatever you want to do with it. I want you to call these particular specific methods and functions from my code. And then I'm going to tell you how to access them. So this is kind of the convention today. This sort of standard is to make an API for your library. So that way programmers have very basic understanding of your code. They don't have to know exactly what your code does. And then you can change your code as long as you don't change the way that they access it. And this is very like, it's just kind of the standard today for how to do this sort of thing. So what does this mean for what we're working on today? Well, basically a bunch of developers got together like we were talking about up here. And they said that JavaScript in the browser specifically should have a very good way of working with audio, because that's a common thing that people want to do in web applications. They want to have audio on their web page, maybe, to do all different kinds of things. Like maybe you want to play a sound file when someone visits your web page. Maybe you want to have sound effects. Maybe you want to make an instrument in your web page. Maybe you want, I don't know, you can imagine all sorts of tasks and objectives that audio might help you fulfill. So basically a bunch of the browser developers got together and they said we should have a way for people to use audio with JavaScript. Like but it should be the same for all the different browsers if possible. And so they did it, and they got together and they made the Web Audio API. So the Web Audio API is pretty incredible. It basically is a pretty unique system of generating audio, sending the audio to a stream, and then the stream is sent to your device speakers by the browser. So the browser kind of takes care of all the audio stuff, just like if you pull up a web page and go to YouTube or something. YouTube talks to the browser and says, hey, send this stuff to your computer speaker. This does the same thing. It says, hey, I'm going to set up some stuff here. Go ahead and send that to the computer speaker via the browser. So that's what it does. And I think this is a good little succinct description of what this does. In fact, it could be even more succinct for what we're going to do today. But basically, it's a little detailed, but it's still quite succinct. So we're going to use the Web Audio API to do the following things. We're going to create an audio context, which is basically going to say, like, this is where we're going to do all of our audio work in JavaScript. Inside the context, we're going to create sources. So these are the things that we're going to be getting the audio from. So in the digital world, you have to create pieces of data that then the computer interprets as audio. So we need something to make that data for us, whether that be a file that we load and play, so like a sound file, like a WAV file or an MP3, or something we're generating in real time, like an oscillator. It's just a moving wave that moves at a frequency that we can perceive when it's played back on a speaker. Or a stream, which is just an arbitrary series of data that we create for the computer to then send to the speakers. So we can ignore effects nodes. We don't necessarily need effects, but you're probably familiar with some audio effects like reverb or delay or distortion, but we don't have to do those things. And then we're going to choose a final destination for the audio. I think the default is going to be, for the most part, people's computer speakers, but you can also choose other destinations. You can basically have a destination be another audio source or something like that. And then, of course, connect all the sources up together and then play the audio. So that's what we're going to do. We're going to just not have the effects. So basically input to destination directly. Yeah, it's very cool. They talk about the target audience for this, like why you would want to do this stuff. Yeah, this is really nice, I think, and I've looked through it a little bit myself to kind of get familiar with this stuff. And I think it's really fascinating because they made it quite musical, meaning that there's a lot of stuff that if you know about music and you're familiar with music, you'll know what they're talking about when you learn about this API, which is very cool. So it's not just sort of a technical, I mean, it's technical from a musical perspective as well, but if you know about music, a lot of this stuff will make sense to you, which is really neat. Yeah, and then they made this article from the technical perspective, this basic concepts article, to kind of explain how it works, like how the API works under the hood. But we don't need to know any of that stuff today. It's not important. I will explain the basics to get us going for just a really simple sound that is going to be interesting on its own. So we talked about these points, like, basically this is the Web Audio API is like the contemporary sort of JavaScript way of making audio in the browser. There's definitely other ways to do it. I mean, audio in the browser has been around, and you can ignore the audio API, but of course, yeah, it's the thing that's sort of hot today, and it's the way people do this stuff, or the way people try to do this stuff now. the browser already knows how to talk to the computer and the speaker. So the web audio API is basically a way for you to do this more easily. It also gives you a way to work with audio like you would with a synthesizer. So it's a much more intuitive way of programming audio. And it's kind of unique to JavaScript. There's other audio APIs out there for different programming languages, but they work a little bit differently. Yeah, so we already also talked about the reasoning behind this. Like most JavaScript runs in the web browser. And this is a common thing, like not just for audio, but for other things. Like if we take a look at the web audio API again, it's under this little web APIs section. And there's tons of web APIs at this point. Like tons of them, because browser developers in general try to identify tasks that everyone's trying to do. And they say, oh, can we make an API for this that all browsers will use and provide that will make JavaScript developers' lives easier? Some ones that I see offhand that are very popular, the Fetch API. This is certainly something that is a pretty big deal and is very important. There's some ones that are a little bit probably interesting and probably not as widely adopted. Yeah. The crypto API is probably quite novel. I doubt that it is. Oh, wow. It's actually been around for quite a while, though. Interesting. Okay. Yeah, it's pretty cool. But yeah, there's tons of these little APIs that people have been working on for quite a long time. And it's, yeah, it's pretty interesting to like take a look at them. But if you get a chance, but yeah, so we're just looking at the web audio API this time. Yeah, so, oh yeah, I forgot to mention the whole nice advantage of all of this is that, so with those other libraries I mentioned, if I want to use something like this in C or in Python, what I would have to do is say import or include this library. I'd have to go download it. I'd have to make sure there's a copy of it where my code is, and then I'd have to say I want to reference it. With the web audio API, if you're in the browser, the whole great thing about this is that you don't have to do anything. It's just part of the browser. So that code is just ready for you to use anytime you want to use it. You can just start using it. So that's what we will do today. So that's another reason why this is kind of cool to do with JavaScript. So you don't have to add extra code, it's just ready to go. All right, so getting started with the actual kind of like use of this thing. We're going to open, first of all, a console. So a console is like somewhere we can immediately run JavaScript code on any web page at any time, whenever we want. So what I'm going to do on my computer, I'm going to press Fn. So it's a Mac. So I have to press Fn and then F12. If you're on Windows, whoops, no. If you're on Windows, you might have to do something different. You might just be able to press F12. And it doesn't matter what browser you're in. If you're in Chrome, if you're in Firefox, it shouldn't matter. But this should open the console. It might open the inspector. I'm not sure. But if it does open the inspector, just click at the top the console tab. I think I have Chrome. And I imagine most people are probably using Chrome or Firefox or maybe Internet Explorer. Which, by the way, if you're using Internet Explorer, you cannot do any of this. So do not use Internet Explorer. You can use Microsoft's Edge. The Edge browser should work just fine. And that also should just work with F12. Okay, so I just opened Chrome and I clicked F12. And it opened basically whatever I had open last. So I need to click on the console at the top. And that worked for me. And then I could start typing. Yeah, okay. Okay, yeah. sorry. So I was just checking Chrome to see what that looks like. All right. Anyway, so I have the console open here. So in Firefox, the way this works is there is a little window that pops up on the left, which is called like the immediate, or it's like the expression window. And then this is the console output on the right. You'll probably see a bunch of junk in there if you opened it on my page. If you open it in a new tab, you won't see any junk except this, I guess. So I'll do it in a new tab so we have less junk. So what I have to do it here is basically I have to start writing the code that I want to execute using JavaScript. So I'm going to go back here to our sort of like instructions and kind of catch up to that point. So once you open the console in your web browser, you can paste the subsequent commands. So these, so as each one is introduced, you can just basically copy and paste those in one at a time and then run them one at a time. So that's kind of the way that you'll do this. And then for web audio content specifically, if you notice, if I copy this command and I paste it in and click run, it doesn't work. And that's because it wants you to perform a gesture on the page before you do this. I think that's because, like, if you open a tab that has audio in it, that audio should not play by default if the user has not engaged with the page, so as not to be very spammy. It's very annoying if you open a tab and it just immediately starts playing audio. So I think that's why they do that. So I've clicked around here, and now if I run it, it runs without a problem. So just a note. At least that's how Firefox works. I think Chrome does the same thing. Okay, so basically, if we want to use the Web Audio API, our entry point to it is something called an audio context. So an audio context is described here. It's basically our way of handling all audio operations. And it allows us to route audio from input to output and all the way in between. So that's why we need an audio context to start with. So we're going to say in JavaScript. So, and I'll actually type these out literally because that way you can kind of see how it shows up if you were to do that. So notice when I start typing that out, Firefox actually recommends me a bunch of different audio things. That's because Firefox is like built with this Web Audio API. It knows exactly what I'm trying to do. It's like, oh, here are all your different options because I'm familiar with this API. I'm providing it to you. So it's actually going to give us an option for audio context. And if I press tab, I can just use that. So if I click run, there's now a variable in JavaScript in scope in the console. Basically, you can think of it like that, sort of on this web page called context that I can now reference. So I'm going to delete this here. I'm going to go back to our sort of tutorial. So once I have a context, I can make requests for different types of audio processes. This is also the way we'll reference all of the different engine options. So we're working with an audio engine, oscillators, filters, etc. So basically the way we're going to make sound. So we have our context, and now we can use one of the sources provided by the API and put them into the context, or basically like have the context get them going. So we are going to do that next. So the next option is we want an oscillator. So an oscillator is just going to make a tone for us. So if I go back here, I'm going to say there oscillator equals context. So the context is the thing that I just made. And I'm going to say dot. And again, Firefox knows what we're talking about here once we've said context. So it's going to say, okay, you're talking about that audio context that you made. Let me show you all of the options that you have when you want to reference that. So that's perfect because we can just go down and say, okay, let me make that oscillator that I wanted to make. So to do that, I'm going to use these parentheses. So open parentheses, close parentheses. And I'm just going to run that. And now we have an oscillator in our context. And of course, oscillators are waves, periodic waves, and they have a frequency. So basically the pitch in hertz, which is cycles per second. So, if you're not familiar with those concepts and stuff, that's okay. If we just go to Wikipedia really quick, I can kind of show you what all this is referring to. But basically, they're trying to make an analogy to like an electronic oscillator. This is terrible. Doesn't really show us what you want to see. It's like this, kind of. So it's something that is vibrating or, expanding, contracting, or it's a repetitive variation in time, over time. So often for waveforms and stuff for sound, you'll see something that kind of looks like this. It's like a little wave and it's drawn out. It's like a squiggle. So that's what we're making. We're making a squiggle. And when I say cycles or periods or hertz, I'm referring to these here. So these like periodic cycles. So going from top to bottom, top to bottom. And then the frequency at which that happens, or like how quickly that happens, or like how often that's happening, that's the frequency in hertz. That's going to be how many times this happens per second. So for our oscillator, I'm going to close this tab too. For our oscillator in particular, I just got rid of my tab. No, I got to do it all again. That's okay. For our oscillator, no, that's all right. That's okay. I only ran.
I'm here following everything, like.
Oh, good.
Like
okay.
not following, but looking at everything you do.
Oh, no, you're all right. I just deleted my tab. That's all. So I deleted all of our work. But that's all right. So I'll just paste all these commands very quickly again. There we go. Okay. Good. Okay, so we're back. So this is all the stuff I lost. So I'm just going to put it back. Hopefully, if you're following along, you didn't delete yours. Whoever is at home, and I'm going to set the frequency of the oscillator, so the pitch, to 216 hertz. This is just a value I chose arbitrarily. And I'll click run again. Okay, so it's running. We're still not going to hear anything because we haven't started it. So it's not oscillating yet. So go back over here to our instructions. Once we've set up the audio source, so the oscillator, we can connect it to the context destination, I should say here, the context destination, so that we hear the audio. So when you create an audio context, by default, the destination for the context is like your computer speakers, or basically whatever the web browser thinks is your audio output for your computer. So that's by default. You can change the destination for the context if you want. But for us, like, we want the default destination just be the browser audio output. Like, so if you open a YouTube video, like whatever that's outputting to, that's like what this is going to use too. So to do that, we're going to do these two commands. So I'll do them manually here. So we're going to say basically oscillator.connect, okay? And then we're going to say connect to where? Inside of the parentheses, we're going to say context, which we made right here, dot destination. So that's, again, our computer speakers. So it's connected now, and you can actually see it outputs something when we do that. It says, oh, okay, you connected, and I'm giving you, in response, I'm telling you the destination that you just connected to. So it has two channels, left and right, for the speakers. It's part of the audio context that we made. it has one input. It has 0 outputs because this is like the final destination. Again, it's got the channel count too. And then it's saying basically like, this is a speaker, which is great because that's like where we want to go. We want to go to our computer speakers. Okay, so now what I want to do is start the oscillator. So I'm going to start it. And we should hear some sound. Or at least I do. Celeste, I don't think, you probably don't hear sound, do you? No, yeah,
no,
okay.
not so far.
That's okay. So what I'll do is I'll change my speakers so you can hear them on the microphone. So now you can probably hear something maybe. Not sure.
No.
If it's audible. Yeah, it's probably a bit too quiet. Let's change the frequency of the oscillator to be loud or to be very high pitched so that we can hear a bit better. So I'm going to select, I'm going to triple this frequency and I'm going to say 600 and 3 times 6, 18, 348. I think that's 3 times 16. Yeah, that is. Whoa, okay. So I'm gonna close that. Very loud.
Now I
Sorry
hear
about
it.
that. Yeah.
But
Yeah,
it doesn't sound too loud. Like,
oh, it wasn't too loud. Okay. It was very loud in my house. So I'll restore this. It's not gonna restore, yeah. So okay. So if you just, I think the best way to do this is honestly not in a blank tab. I think the best way to do this is probably just to pull up an actual tab like this one. That way you don't have weird tab problems. So basically that was the overview. We did a very quickly, all we had to do was, as you can see here, basically 4 lines of code. So we made a context, or 5 lines of code. We made a context. We created an oscillator in the context. We set the oscillator frequency, and then we connected it to the speakers of our computer, and then we started it. So one thing I wanted to mention, which I didn't do just now, but let me do it again. So I'll create the context. I will create the oscillator. And we can run all these commands one after the other, as long as they're in the correct order. So I'm going to create the oscillator. I'm going to set the frequency of the oscillator to be double this time, so 32. I'm going to connect it, and then I'm going to start it. So you can probably hear that, I think, right? Yeah, great. Okay. So
yes, I hear it.
Awesome. Okay, so one thing that's really helpful for the web audio API is like if we need to stop the audio, like earlier, what I should have done, instead of having to close out your tab and everything like that, you don't have to do that. You can use your context to suspend and resume the audio processes. So since it's an audio engine, it can handle all these things for you. So if I want to say, whoa, like, don't play anything right now, I can just suspend. And it'll say, it basically is responding with this little JavaScript object thing that's saying like, hey, I saw that you suspended, and I'm going to give you this thing that will let you unsuspend it if you want. Or it'll tell you when it's not suspended anymore, stuff like this. So that way I can like kind of make some tweaks or adjustments. For example, I can reduce the frequency of the oscillator to something lower and more palatable. I can run that, and now when I resume by saying context.resume, it's now at the lower frequency, which you probably can't hear, I would imagine. Yeah, but that's okay.
Yeah, I can now.
Yeah, that's all right. Okay, but yeah, so this is really helpful. So if you ever run into a situation where you're like, whoa, very loud sound, just run suspend. You can also totally kill everything by saying close. And now everything is, there's nothing, you can't resume it. You can't even, you can still refer to it. And I think if you just say open, Nope, you can't even say open. Let's see. I don't know if there's actually a way to get it back. But anyway, it's not important. We would just make another one. In our case, it's not a big deal. But yeah, if we look at the documentation, though, we can probably find a way to get back. So this is the audio context. This is what we've been using. There's close. There's resume, suspend. Yeah, I think maybe it's just dead. Which is okay. We'll just make another one. Okay, yeah, I think it's dead. So that's, anyway, just a helpful tip when working with the web audio API. So if you were making an application, like if you were writing some code to make an audio application or an audio tool, these things would be very helpful. For instance, if you had a pause button, or if you had a play button, you could have the pause button basically just call your code, context.suspend. Okay, so now that we're kind of towards the end, I wanted to provide this nice little example. It's like a little audio, kind of cool, sort of interesting audio little snippet. I am unable to control my output audio. Maybe I can control it from Firefox. I don't think I can. Nope. Well, okay. So this might be kind of loud. Oh, wait, no, I have a solution for that. All right, no problem. So if it's loud, that's okay. But basically, I actually got this code from a friend of mine. They came across it, but it's like basically a very fast way to make a cool sounding little, I guess maybe you could kind of call it an instrument. That's a little bit debatable, but it does make some cool sounds. So you can copy paste this and I'll kind of walk through what it does. It uses some sort of very succinct syntax. So it might look a little bit confusing, even if you do know a bit of JavaScript, but I will try to explain in detail what's happening. So first things first, we're going to make an audio context. And by the way, when you paste code in here, you can run just individual snippets of it by, on a Mac, Command Enter, and I think on Windows, probably Control Enter. On Chrome, I think if you pasted all this in, it would probably just try to run all of it. So let me see, actually. On Chrome, if you do that, what happens? Oh yeah, okay, no, it doesn't. Okay, great. So on Chrome, you can paste it all in, and I'm pretty sure you can also, same principle. No, you have to run it all. Yeah, okay. Anyway, whoops, sorry. All right, so that's what happens if you run it. But anyway, we're gonna walk through it first. So first, I'm making the audio context, just like we were very used to doing that. I just named it something else this time. I named it CTX to be a little more brief. Then I made this variable O, and I set it to be an oscillator. Same thing we did before, create oscillator. I just put all this stuff on one line. You can do that in JavaScript as long as everything's separated by semicolons. So this would be the same thing as putting this down here, and this down here, and this down here, which now these are just the same commands you're already familiar with. So we set the frequency, we connect it, and then we start it, connected to the context destination. So no different there. I just put it all in one line because this is everything that we need to do for the oscillator. All right, so then the stuff that is a little bit different, right? If I were to run this, so Command Enter. So now we just have, I mean, again, you won't be able to hear that. It's just this one bass tone. So, not super interesting. That's what we already did. So to make this more sort of interactive, or not interactive, but kind of to introduce some dynamic changes, we can use JavaScript. Basically, not necessarily the web API, the web audio API, but just JavaScript, like programming. So first of all, we're going to set a speed. So this is going to be the speed at which the oscillator is going to change pitch. So I'm setting it to 500. 500 is going to be milliseconds, so it's half a second. 500 milliseconds is half of 1 second. And then I'm going to create a function called random. In JavaScript, you can do this in a couple different ways. This is one way of making a function, is with these parentheses, and then this is called an arrow or a lambda. But that's a pretty complicated looking way to make a function. So another way to do that is to say random is equal to a function which takes one parameter, max, and inside of the curly braces, we will define what the function does. I'll copy paste this here. And all it does is it returns this. So math.floor, which is going to round down. So basically it's just rounding down. So like if you had 5.8, taking the floor of 5.8, it gives you 5. 7.2 gives you 7. So it just rounds down. And what is it going to round down? It's going to round down this part here. So we could even put this on its own line to be super clear. So it's that doesn't look that much clearer, honestly. So it's rounding down the result of this. So it's basically the result of a random number between 0 and 1. That's what random, this function does. And then multiplies it by the rounded down input to this function. So the whole point of this is basically, I want to provide a number that is the maximum possible number that I want to observe from this function, random. And then I want you to give me a random number that lies somewhere between 0 and this maximum number. So this is very helpful if like you want to generate a random number between like, I want a random number between 0 and 300. Then all I have to do is say random 300, or in this case, where I'm actually using it, random 1300. So this function is basically going to provide a random number between 0 and 1300 every time you call it. So this is useful for us because what we want to do is we want to generate a bunch of random pitches. So I'm going to go ahead and run, whoops, oh God, wait, yikes. I'm going to cut this and I'm going to close that context.
That's nice.
Yeah. All right, I'm going to close that context. Oh, whoops. Huh. We still have a context running in the background, which is interesting. And I don't know how to close that one. I don't think it's this. Yeah. Okay. Let's see if I can access it. Yeah, so this original context that I made is still running, which is pretty annoying. Okay, that's all right. If I say, oh, yeah, it doesn't want to get rid of the sound, which is unfortunate. So I guess if you make multiple audio contexts, be careful because they'll stick around. Yeah, I can't exactly, I don't think I can stop it. Okay, one way to fix this, well, first of all, we're going to refresh the page. That's what we're going to do. So that'll get rid of it. One way to fix this is to use a constant in JavaScript, which means it'll never be redefined. So we'll only ever have one context. So that's helpful. See, every time I try to rerun this, it'll give me an error. It'll say, oh, you can't do that. You already made one. So that's nice, because then we'll only have the one to deal with. So let's go back to this, and we can basically get back to our little sample. So we know what this function does now. I just wrote it out in a different way earlier, but the idea is that I give it a maximum random value, and it generates a random number between 0 and that value. This part is a little more complicated. I'll try to explain it really quick. The gist is that basically this is a function that is going to, you could read it like this. It's going to set the frequency value to a random number between 0 and 1300 Hertz. It's going to set the speed to a random value between 0 and 1000, which is the speed at which we're changing pitch. So basically every time we change pitch, we might change pitch faster next time, or slower the time after that, or faster next time. And then what it's going to do is actually do something a little bit weird. It's actually going to call this, like itself, the same function again on a timeout. That is basically going to happen based on the speed that we just updated. So it's a little bit confusing sounding, but the way that works out is basically this function is going to call itself again and again and again and again and again forever. At different times.
Always randomly.
Yes, always randomly, right? At random speeds. The first time it'll happen though is at this speed, a speed of 500 milliseconds. And then after that, yeah, it'll be random. So exactly. So we're going to go ahead and run it. Oops, I forgot to run the other parts of it. So I need to make my oscillator first. So we'll go ahead and paste that in. So now that I've connected it and started it, I've got a bass tone going in the background, which again, you wouldn't be able to hear because my microphone is not sensitive enough. So now I'm just going to copy this section, paste that in, and I will run it. So it kind of sounds like a modem. If you ever had or like a DS, or what do they call it? I think like a DSL modem or something, or like a dial-up modem is kind of what it sounds like. Yeah, so this is kind of loud though. So what we can do is use, I'm actually going to turn it down quite a bit because it's very loud. So the last thing we'll do really quick is I want to introduce this idea of a gain node. So a gain node is like an oscillator node, except it is going to let us set the gain of any audio going into it, and then we can connect it to the destination. So this is really nice because then basically it's a volume control. So this is really useful. So what I'm going to do is I'm going to add that in to our little code snippet here. So I'm going to copy this. I'm going to paste this in. And instead of connecting the oscillator here to the context destination, what I'm going to do is actually, I'm going to say var g equals ctx.create gain. I'm going to make a gain node. And then I'm going to say g dot, let's see. They tell us how to do it here, which is quite nice. G, so you could say set value at time. I think you can also just say set value in the documentation, which is very nice. We can see how to do that. Oh, we can just say, no, this is read only. This says read only. Oh, maybe we can say this. G.gain. .5. Maybe that will work. Then what we'll say is G.connect. We'll connect this to the destination, so the speakers. And then G.start, so we'll start the node. And then what we'll do is connect the oscillator instead to this gain node. So we'll say G.destination, I think should be the way that would work. And since it's an audio node, I'm pretty sure this should work fine. Yeah, context. Let's go back to connect. Connect. In order to connect, we have a destination. Oh, we can just pass it the node. Okay, great. So we can just say connect G like that. Okay, so then basically we're going to connect the gain node to the speaker and then the oscillator to the gain node. And this should work, I think. Oh, G start is not a function. Okay, maybe you don't have to say start. Let's try that. I don't think it worked. I think I messed up the gain value part. Oh yeah. No. It should be okay. Create gain. Gain.value. Oh, it did work. Okay. I don't know what happened, but also I'll change the output, and then it's still kind of loud. So what I'll do is now, since I have this gain node, I can say G.gain value. I can say 0.2, and then you can probably not really hear it now, or it's softer, hopefully.
I hear it. Like
oh,
soft,
okay.
But in this side, it's like soft.
Yes. If I set it to 0, you should not be able to hear it at all. So now it's gone. Right. Okay. And then if I go to 1, it's going to be really loud. Right. Okay. Yeah, that's it. That's kind of a quick tutorial on the Web Audio API. Certainly, there's way more to it than what I just showed, but hopefully it's enough to get you interested or get you started, or maybe give you some ideas of all the kinds of things that you can do. Yeah.
Really cool. Really cool. I appreciate sharing this because it's kind of different for what we look the previous sessions.
Yes. Yeah. Absolutely.
But it's also like something that people can go ahead and create and.
Yeah. And it's really not too hard. I mean, this stuff, you don't even have to do this kind of stuff to get very interesting results. But I think this stuff is pretty straightforward, making a node, setting properties, and then starting it. So.
All right. So I just want to mention that next week is the last session of the year. We're going to be meeting in person at the library in Ives Square. And would you like to share what we're doing?
Sure, yeah. So we're going to be taking a look at circuit bending. So circuit bending is this sort of concept or like practice that was founded, and I'll link this kind of stuff at the beginning of the session next week. But it was founded by this person whose name escapes me, but basically I want to say as early as the 70s or the 80s, but basically the practice of taking a device that was designed for something, usually to make sound, and making it do what it was not supposed to do. So yeah, we want to make things basically sound really weird or do things that are totally unexpected. And we can do it safely as long as it's operating at a certain current and voltage. So battery-powered toys are really good candidates for that.
So we're gonna still probably be virtual, but the hands-on of the program is gonna happen at the library. So hopefully we will see.
Yes, yeah. So
Okay.
please come in person if you're able to, and you are comfortable enough doing so, for sure, because we'll have some toys.
All right, and then will be the last session of the year, and then we will resume in January with a new topic. So
yeah.
All right. Okay. So have a good night. Have a good night, everyone, and thank you for joining us tonight. And hope to see you next Thursday.
Yep.
Okay. Bye.
All right. Bye.